This is K8BYP, formerly an HVAC controls engineer with HVAC and appliance repair and installation experience, by the way, to show you a serious screw-up that Trane made in the XL14 heating and air heat pump unit, external package unit. Here's the compressor and the compressor house and the compressor compartment. See the wiring coming through the indoor fan compartment down and under that pipe. This is a heat pump. Heat pump for heat, heat pump for cold with reversing valve. On the surface of that compressor, a warning label, hot. And they don't mean maybe. The wiring underneath that pipe was strapped to it tight with a nylon wire tie. And here's what happened. See the top yellow wire? See a little slice in it? Well, it's not a slice. That's where the insulation's melted. PVC, low temperature insulation. Pressed against that screaming hot pipe, it flowed the insulation away. It didn't burn it, but it caused the insulation to flow here and here, exposing that copper wire. That wire goes to one of the pressure cutout switches on the 24-volt line that goes to the compressor contactor. And what this unit was doing is that when it started in AC, it would run a few seconds, about 10 seconds, and then the compressor and the outdoor fan would shut off. It might come back on for 2 seconds and shut off. It might come on for 5 or 8 seconds and shut off. Very intermittent. And I went through this system. I checked the outdoor and the bottom coil sensors. Perfect. And having controls engineering experience in HVAC and knowing all about processors, I says, this fault can't be. This cannot be a bad control board. Maybe a bad solder joint on the board, but in a unit that was put in 2015, not likely. So, after reasoning that this is a really strange fault, I unpowered the unit, took the compressor cover off, and immediately laid eyes on those wires improperly strapped to that pipe. And see how overheated that pipe has been? It's starting to turn brown. It got so hot. And here's an example of how hot those lines get. See these stubs? That's a stub, and that's a stub for the low pressure and high pressure cutouts. See the different line sizes. But they're on these stems that are brazed in to isolate these switches from the heat on those lines, because the heat will destroy them. So that's why they're on stems. That looks like a process stub, but it isn't. There are process stubs or Schrader valve stubs in other places up by the SOV. But the fix was to cut that wire tie away. Don't use a knife. Don't risk nicking that copper and causing a break and a leak. But cut the wire ties away. There were 4 or 5 of them, one here, a bunch on this bundle of wiring. I put electrical tape around the wiring to just hold together so it can't get caught in the cover when the cover's reinstalled. But I wrapped fiberglass sleeving. I tied a knot here and then wrapped it spiral around those wires, insulated wires, covered them with the fiberglass mesh, and then put tape around to hold it. So if these shouldn't touch this, but if they do, the heat won't get through the fiberglass. But again, reading is fundamental. Hot surface. And if that surface is hot, so is that one. And that one's probably hotter than that one. This makes a case for not just summarily running out and start changing sensors and control boards. 2015 unit. Shouldn't be bad. What we've got here is the so-called Defrost control board. It's really a microprocessor, probably some PIC variant under the version 2.0 label. But this is a computerized control that runs a unit. It doesn't just do defrost. But the problem is we don't see many components on the top. What we do see are big, heavy, clunky relay, big socket, headers. And on the bottom, surface mount. And this spells trouble, because almost always when there's a mismatch like this with surface mount and these big, heavy, odd form components, but there will usually be bad solder joints on the odd form components. And on that relay, there were. This solder joint here was broken, and that one was broken. So I redid that, and that. Checked the rest of the components with a magnifying glass. The board is covered with conformal coating plastic. See the shiny? That keeps moisture and contaminants in the air from attacking the solder joints in the copper. But take that board out. Hold the board by the edges. Do not touch the terminals. If you're just an HVAC guy, you don't understand maybe that this is a static sensitive unit. You take this out, disconnect it. Touching the wrong terminal on that controller or on this board can destroy that microcontroller. So, static safe work surface. Number 2, failure item, electrolytic capacitors. That's a 470 microfarad of 50 volts. Date coded 2014, so it's not that old, but it's too old to make me happy. So, it got replaced. Not real difficult. What's required to do that is solder wick, something to scrape the conformal coating away with, QD contact cleaner to wash the coating away, Q-tips to wipe it away, rosin solder flux to put on the solder, and temperature controlled soldering station. Never use one without a soldering temperature control. But scrape the conformal coating away, a little bit of flux, resolder these odd forms. The odd form problem is that the surface mount components have a different temperature profile and they have no mass. When this board is moved through a soldering process, the surface mount components, especially if they're glued down like these are, don't move. These odd form components are massive and heavy, and when that board moves, these parts vibrate and move. And when they move, that makes bad solder joints. There'll be rings around the joints. Probably take a magnifying glass to see it. But that board should be good now. So I'll go throw it back in unit and test it. But this was really a strange problem because it worked fine in heat pump, except one time I saw the outdoor fan shut off and it was not in defrost. So the wire that was shorted is in the cutout line from this board, which sends out the yellow command to start the compressor contactor. That goes through the LPCO and HPCO, and one of those wires was shorted against that copper tube. When that does, it takes the voltage away from the compressor contactor, and the compressor contactor also shuts off the outdoor fan. So this problem was difficult for me to figure out. It would drive an HVAC technician up a wall. So one of the first rules in troubleshooting is just have a good general look. This also illustrates why we don't hire uneducated, untrained people to do assembly work like that. Because someone that doesn't understand how hot that pipe gets made the mistake of zip tying those wires to that hot pipe, and it caused a mess. This is why we got to train people beyond just their little job. So there's the HVAC story. KBYP did it.